Far beyond, adrift in the vast, suffocating darkness between the stars, a planet moves in silence. Its name is K2-18b, sterile, distant, as cold as the cosmos itself. It orbits a faint, fading star more than 100 light-years from Earth. What the James Webb Space Telescope has uncovered is more than data. It's a murmur that could swell into a revelation. A clue so striking, so intimately connected to the essence of life, it compels us to wonder, could this be the first subtle pulse of a living alien world? How far away is K2-18b? Well, it's definitely not like taking a trip to the moon or even Mars. This planet is an incredible 124 light-years from Earth. A light-year is the distance light travels in a single year, and since nothing moves faster than light, that's really saying something. So, the light from K2-18b's star takes 124 years just to get here. If you wanted to count that in miles, you'd be looking at around 700 trillion, that's a 7 followed by 14 zeros. It's such a vast distance, it's almost impossible to wrap your head around. Compared to that, our solar system is just a tiny sandbox on the edge of a massive cosmic beach. Reaching it might seem out of the question, but scientists had a clever trick up their sleeve to spot it. How did we even discover something so distant and hidden? We didn't spot the planet directly. Back in 2015, a space telescope called Kepler spent years observing countless stars. It looked for tiny dips in their brightness, subtle flickers that happen when a planet passes in front of a star, briefly blocking some of its light, like a mini eclipse. Kepler noticed that the star K2-18 kept dimming in a repeating pattern. That regular flicker was a clue, something large was orbiting the star in the darkness. That something turned out to be K2-18b. We detect planets using a method called the transit method, by watching for tiny dips in a star's brightness when a planet passes in front of it. This technique has led to the discovery of thousands of planets beyond our solar system, revealing that our galaxy is teeming with worlds. But once we spot a planet, the next big question is, what kind of world is it? Take K2-18b, for example. It turned out to be nothing like Earth. When scientists measured its size, they were stunned. It's massive. K2-18b is over 8 times heavier than Earth and more than 2.5 times wider. Picture Earth inflated like a giant balloon. That kind of size puts K2-18b into a category known as a subneptune, larger than rocky planets like Earth or Mars, but smaller than the icy giants like Neptune and Uranus that orbit in the outer reaches of our own solar system. Here's something curious. Planets around the size of subneptunes are everywhere in the galaxy. They might even be the most common type out there. But strangely, our own solar system doesn't have a single one. We've got small rocky planets and giant gas worlds, but nothing in between. That makes subneptunes a real puzzle. What are they actually made of? Are they massive rocky planets wrapped in thick atmospheres? Failed gas giants that never quite made it? Or maybe they're something entirely different, like water worlds? Unlocking the secrets of subneptunes is a major quest for planetary scientists, and one planet in particular, K2-18b, has become a key player in the mystery. What made K2-18b stand out wasn't just its unusual size, it was its location. This planet orbits its star, K2-18, right in the habitable zone. That doesn't guarantee life, but it's what scientists call the Goldilocks zone, not too hot, not too cold. It's the sweet spot where, if the planet has the right kind of atmosphere, temperatures could allow liquid water to exist on the surface. And since water is essential for life as we know it, a strange, oversized planet sitting in this potentially perfect zone sparked a lot of excitement among scientists. But could a planet orbiting a dim red star really be friendly to life? Just because K2-18b is in the habitable zone doesn't mean it's a nice place to live. Its star, K2-18, is a red dwarf. These stars are smaller, cooler, and much dimmer than our Sun. They are the most common stars in the galaxy, though. To stay warm enough for possible water, K2-18b has to orbit really close to its star. It zooms around K2-18 in only 33 days. Our Earth takes 365 days to go around our Sun. Being so close can cause issues. Planets orbiting red dwarfs might become tidally locked, meaning one side is always facing the star, perpetually day, while the other side is in constant darkness, eternal night. Picture one half of the planet burning hot and the other freezing cold. This extreme contrast could make life difficult. Plus, red dwarf stars have a fiery temper, occasionally releasing massive bursts of energy called flares. These flares could blast K2-18b with harmful radiation, possibly stripping away its atmosphere over time. Is K2-18 a calm star, or is it a stormy one? We're still working that out. And what about the planet itself? It's so heavy, the pull of gravity there must be super strong. What's deep inside? Could the crushing pressure turn water into weird kinds of solid ice, even if it's warm? Does it even have a solid surface to stand on? Maybe it's more like Neptune, just a giant ball of gas that gets thicker and thicker toward the middle. Its huge size makes everything complicated. We don't really know what the insides of sub-Neptunes are like. The biggest question of all revolves around its atmosphere. What kind of gases make up K2-18b's air? Is it dense, composed mostly of light gases like hydrogen, or something else entirely? The air holds the answers, it regulates the temperature, shields the planet, and could even offer evidence of life. Determining the composition of K2-18b's atmosphere was the ideal challenge for the most advanced space telescope ever created. But how could a telescope, trillions of miles away, possibly sense a planet's air? Is this really a sign of alien life? Finding aliens would be the biggest news ever, so scientists have to be super careful. Even though the DM signal looks stronger, there are still big reasons to wait before shouting aliens. First, how sure are they? The signal is still only at the 3 sigma level. That's a science way of saying how sure they are. 3 sigma means there's still a small chance, about 1 time out of 370, that the signal is just random luck, like static on the telescope looking like a real signal by accident. That sounds small, but for huge news like finding life, scientists want to be much surer. They want 5 sigma proof. That means the chance of being wrong is tiny, less than 1 in a million. The DM signal isn't very strong yet. Big question number 1, is the signal genuine, or could it just be random static? They need more evidence. Next, even if the DMs are real, do they necessarily indicate life? We know life produces DMs here on Earth, but K2-18b is completely different. It's massive, could have extreme pressure deep inside, has a different atmosphere, and orbits a different type of star. Could some unusual chemistry be at play there, perhaps deep within its ocean, if it has one, or high in its atmosphere, affected by the star's radiation, that produces DMs without any life at all? Scientists have considered known processes that could create DMs, but they don't think these methods would generate enough. What about processes we haven't discovered yet? We shouldn't assume alien planets operate the same way Earth does. Big question number 2. Could some unknown, non-life chemistry be responsible for this gas? Finally, the amount of DMs they might be detecting is unusual. The signal suggests there might be thousands of times more DMs in K2-18b's air than in Earth's air. If it is life, those alien microbes must be working incredibly hard, making way more DMs than all life on Earth. Professor Maru Sudan thinks maybe this is normal for high-end planets, but it's still strange. Does finding so much make life more likely, or does it maybe point to some powerful non-life source that we haven't thought of? It's a real head-scratcher. Big question number 3, why is there maybe so much of this gas? Is it life working overtime or something else entirely? What exactly are scientists looking for when they talk about signs of life? This whole search is about finding biosignatures. That's just a science word for a sign of life, something that likely wouldn't be there unless living things were making it. DMs are a promising biosignature because life is responsible for most of their presence here on Earth. However, detecting them is challenging, and we must be cautious of false positives. For instance, oxygen is a gas produced by life on Earth, but scientists know that some planets, even without life, can have oxygen in their atmospheres due to non-biological processes. So, simply detecting oxygen isn't definitive proof of life. This is why scientists are looking for multiple signs. They might search for a combination of gases in the atmosphere that couldn't coexist for long unless life is continuously producing them.